Start our journey 4.6 billion years ago, when the solar system was just a swirling cloud of gas and dust. This vast nebula made up of elements from earlier stars began to collapse under its own gravity. As it spun faster, most of the material gathered at the center to form the sun, but not all of it. Some remained in a disk around the young star. This disk would become the birthplace of the planets, including our very own Earth. The process was chaotic and energetic, setting the stage for the dramatic events that would follow. Within the spinning disk, tiny particles of dust and ice began to stick together. Over time, these grains collided and clumped, growing larger with each impact. Eventually, they formed planetesimals, rocky bodies that could be kilometers across. These planetesimals were the building blocks of planets. Their gravity pulled in more material, and as they grew, collisions became more frequent and violent. The early solar system was a dangerous place, full of impacts and constant change. As planetesimals continued to collide, some merged to form even larger bodies called protoplanets. These protoplanets had enough gravity to attract more debris, growing rapidly in size. The process of accretion, where smaller objects stick to larger ones, was relentless. Over millions of years, the largest protoplanets began to dominate their regions, sweeping up most of the material around them. One of these would eventually become Earth. About 4.5 billion years ago, one of these growing protoplanets gathered enough mass to become the early Earth. This young planet was a hot, molten sphere, constantly bombarded by leftover debris from the solar system's formation. The surface was unstable, with volcanoes erupting and lava flowing freely. It was a world in flux, far different from the stable blue planet we know today. One of the most dramatic events in Earth's early history was the giant impact. A Mars-sized body, often called Theia, collided with the young Earth. The force of this impact was unimaginable, melting much of both bodies and blasting debris into orbit around Earth. Over time, this debris coalesced to form the Moon. This event not only gave us our Moon, but also changed Earth's tilt and rotation, influencing the planet's future evolution. After the chaos of the giant impact, Earth began to cool. The molten surface slowly solidified, forming a thin crust. This crust was fragile and often broken by volcanic activity, but it marked the beginning of a more stable planet. As the surface cooled, gases escaped from the interior, creating a primitive atmosphere. The stage was set for further changes that would make Earth habitable. Earth's first atmosphere was nothing like the air we breathe today. It was made up of gases released by volcanoes, mostly water vapor, carbon dioxide, and nitrogen, with almost no oxygen. This thick, toxic atmosphere trapped heat, keeping the planet warm. Over time, as volcanic activity continued, more gases were added, slowly changing the composition of the air. For hundreds of millions of years, Earth was battered by asteroids and comets. This period, known as the Late Heavy Bombardment, brought both destruction and new materials to the planet. Some of these impacts may have delivered water and organic molecules, essential ingredients for life. The constant impacts kept the surface unstable, but also helped shape the planet's future. One of the most important changes in Earth's history was the arrival of water. Some water may have come from volcanic outgassing, but much of it likely arrived on comets and asteroids that struck the planet. As the surface cooled, water vapor condensed to form the first oceans. These early seas covered much of the planet, setting the stage for the emergence of life. As Earth cooled further, vast oceans formed, covering much of the surface. These early oceans were likely hot and acidic, but they provided a stable environment for chemical reactions. Over time, the oceans played a crucial role in shaping the planet's climate and geology. They also became the cradle for the first forms of life. With oceans in place, the next big change was the formation of continents. Lighter rocks floated to the surface, forming large landmasses that would become the continents. These early continents were small and constantly changing, but over millions of years they grew larger and more stable. The movement of these landmasses would eventually lead to the process we know as plate tectonics. As the crust thickened and cooled, it broke into large pieces called tectonic plates. These plates floated on the semi-molten mantle below, moving slowly over time. Plate tectonics reshaped Earth's surface, creating mountains, valleys, and ocean basins. This dynamic process is still at work today, driving earthquakes and volcanic eruptions. Deep inside the young Earth, the core began to differentiate into a solid inner core and a liquid outer core. The movement of molten iron in the outer core generated a magnetic field. This magnetic shield protected the planet from harmful solar radiation, making it safer for life to eventually develop. The magnetic field is still vital for life on Earth today. As volcanic activity continued, the composition of Earth's atmosphere slowly changed. Water vapor condensed into rain, removing carbon dioxide from the air and cooling the planet. Over time, nitrogen became the dominant gas and the atmosphere grew less toxic. These changes made Earth more hospitable, paving the way for the first living organisms. With oceans and a more stable atmosphere, the stage was set for life to begin. The first living organisms were simple, single-celled microbes that appeared in the oceans. These early forms of life were the ancestors of all living things on Earth. Their existence marked a turning point in the planet's history, beginning the long process of biological evolution. Some of these early microbes developed the ability to use sunlight to make food, a process called photosynthesis. This innovation allowed them to thrive and multiply, and it had a profound effect on the planet. Photosynthesis released oxygen as a byproduct, slowly changing the composition of the atmosphere and paving the way for more complex life. As photosynthetic microbes flourished, oxygen began to build up in the atmosphere. This event, known as the Great Oxygenation, transformed the planet. Oxygen was toxic to many early life forms, but it also allowed new, more complex organisms to evolve. the atmosphere became more like the air we breathe today, setting the stage for the next chapter in Earth's story. With more oxygen in the atmosphere, some of it formed ozone, a molecule that absorbs harmful ultraviolet radiation from the sun. The ozone layer acted as a protective shield, allowing life to move from the oceans onto land. This crucial development made Earth even more hospitable for a wide variety of organisms. Over hundreds of millions of years, the continents continued to drift across the planet's surface. This movement, driven by plate tectonics, created new oceans and mountain ranges. The shifting continents influenced climate, ocean currents, and the evolution of life. Earth's surface was always changing, shaped by powerful geological forces. At several points in Earth's history, the continents came together to form giant supercontinents like Rodinia and Pangaea. These supercontinents eventually broke apart, reshaping the planet's geography. The cycle of assembly and breakup had a major impact on climate, sea levels, and the evolution of life. Throughout its history, Earth's climate has changed dramatically. Ice ages covered much of the planet in glaciers, while warm periods melted the ice and raised sea levels. These fluctuations were driven by changes in the planet's orbit, volcanic activity, and the movement of continents. Climate change has always been a part of Earth's story. Earth's history is marked by several mass extinctions when large numbers of species disappeared in a short time. These events were caused by volcanic eruptions, asteroid impacts, and rapid climate changes. Each extinction reshaped the planet's ecosystems, clearing the way for new forms of life to evolve. After each mass extinction, life bounced back in new and unexpected ways. New species evolved to fill empty niches, leading to bursts of diversity. Over time, plants, animals, and fungi colonized every corner of the planet, creating the rich tapestry of life we see today. About 600 million years ago, complex multicellular life appeared in the oceans. These organisms had specialized cells and tissues, allowing them to grow larger and more diverse. The Cambrian explosion, around 540 million years ago, saw a rapid increase in the variety of life forms, including the ancestors of most modern animals. Eventually, some plants and animals made the leap from water to land. This transition required new adaptations like sturdy skeletons and ways to prevent drying out. The colonization of land opened up new habitats and opportunities, leading to the evolution of forests, insects, and the first land-dwelling vertebrates. For over 150 million years, dinosaurs dominated the land. These remarkable creatures came in all shapes and sizes, from tiny bird-like species to massive long-necked giants. The age of dinosaurs was a time of great change, with new plants, insects, and mammals evolving alongside these ancient reptiles. About 66 million years ago, a massive asteroid struck Earth, causing a global catastrophe. The impact triggered fires, blocked sunlight, and led to the extinction of the dinosaurs. This event cleared the way for mammals to rise and eventually dominate the land. With the dinosaurs gone, mammals diversified and spread across the planet. Some grew large while others adapted to life in water, air, or underground. Over millions of years, mammals became the dominant animals on land, setting the stage for the evolution of primates and eventually humans. Among the many groups of mammals, primates evolved unique traits like grasping hands and forward-facing eyes. These adaptations helped them thrive in trees and eventually led to the evolution of apes and humans. The story of Earth's formation is also the story of our own origins. In the last few million years, Earth has experienced a series of ice ages. Glaciers advanced and retreated, shaping the landscape and influencing the evolution of plants and animals. These cycles of cold and warmth have played a major role in shaping the world we know today. Modern humans, Homo sapiens, appeared about 300,000 years ago in Africa. With their large brains and ability to use tools, humans quickly spread across the globe. Our species has had a profound impact on the planet, shaping landscapes, ecosystems, and even the climate. About 10,000 years ago, humans began to farm and domesticate animals. This agricultural revolution allowed people to settle in one place, build cities, and develop complex societies. Civilization brought new challenges and opportunities, changing the face of the planet forever. In the last few centuries, the Industrial Revolution transformed human society. Machines, factories, and new technologies allowed people to produce goods on a massive scale. This era brought unprecedented growth and change, but also new environmental challenges for the planet. Today, Earth is a vibrant, dynamic planet teeming with life. Its surface is shaped by powerful forces, tectonics, weather, and the actions of living things. Our planet continues to evolve, and humans play a major role in its ongoing story. The formation of Earth is not just ancient history, it's a process that continues every day. Beneath our feet, Earth is made up of several layers: the crust, mantle, outer core, and inner core. Each layer has unique properties and plays a role in the planet's geology. The movement of these layers drives earthquakes, volcanoes, and the creation of mountains. Earth is unique in the solar system for its liquid water, active geology, and abundant life. Its magnetic field, atmosphere, and distance from the sun make it a rare oasis. These features have allowed life to thrive and evolve in countless ways. The Moon, formed from the debris of a giant impact, has played a crucial role in Earth's history. Its gravity stabilizes the planet's tilt, creating regular seasons. The Moon also influences tides, which have shaped the evolution of life along coastlines. Earth orbits the Sun at just the right distance for liquid water to exist. Its position in the solar system, along with its size and composition, has made it a haven for life. The other planets offer a stark contrast, highlighting Earth's uniqueness. From towering mountains to deep ocean trenches, Earth's surface is constantly changing. Erosion, weathering, and tectonic activity reshape the land over time. These processes create the landscapes we see today and will continue to transform the planet in the future. One of the key processes on Earth is the carbon cycle. Carbon moves between the atmosphere, oceans, land, and living things. This cycle regulates the planet's climate and supports life. Human activities have begun to alter the carbon cycle, with important consequences for the future. Looking ahead, Earth will continue to change. The continents will drift, climates will shift, and life will evolve. Human actions will play a major role in shaping the planet's future for better or worse. The story of Earth's formation is ongoing, and we are all a part of it. As we learn more about Earth's history and formation, we also understand the importance of protecting our planet. Conservation, sustainable living, and scientific research are all vital for ensuring a healthy future. By caring for Earth, we honor its incredible journey and secure a better world for generations to come. When we look at Earth from space, we see a small, fragile world floating in the vastness of the universe. This perspective reminds us of how unique and precious our planet is. The story of Earth's formation is a reminder of the incredible forces that shaped our home and the responsibility we have to protect it. Earth is not just a rock in space, it's a living planet shaped by geology, climate, and life itself. Its story is one of constant change, resilience, and adaptation. As we continue to explore and learn, we deepen our appreciation for the planet we call home. The formation of Earth is a story billions of years in the making, but it's far from over. Every day, new discoveries reveal more about our planet's past and future. By understanding how Earth formed, we gain insight into our place in the universe and the incredible journey that continues to unfold.